2.5, more equation solving, 2.5a, page 229 in your college algebra book. And when you have rational equations, which means you have rational expressions in them, what we're doing is we're solving equations involving multiplying both sides by the least common denominator in order to get rid of the fraction. So if you look right away at example number 1, we have a rational equation, and what I mean by rational expressions is we have two terms that are rational, x minus 8 over 3 and x minus 3 over 2. In order to solve this, we're going to multiply the entire thing by the common denominator, and in this case it is 6, and that allows me to cross this out with 1 and this out with 2, and this part over here is also being multiplied by 6, so we're going to cross out the 2 and put a 3 here. Okay, so I guess I should have put the 2 here. So we multiply the entire thing by 6 and then cancel what we can, and we end up with 2x minus 16 plus 3x minus 9 equals 0. And then we got rid of the fraction. We can go ahead and solve it. In this case we'll get 5 because it's a linear equation for our x, and you can graph it from there. Okay. So very, very important, top of page 231 where it says caution. So they've got this big long explanation, and basically all they're saying is you cannot do that method that I just did in example 1 unless there's an equal sign involved. You can't use it unless there's an equal sign. So when you're trying to clear an equation of fractions with an equal sign, you multiply the entire equation, both sides of the equal sign, by the least common denominator, and then it'll clear everything of fractions. But if there's no equal sign there, you can't use this problem. Okay? If you have an expression, to simplify a radical expression, you have to find the least common denominator and then just add them. You will not be able to get rid of the fraction that way. So if we had the x minus 8 over 3 plus x minus 3 over 2, you find the common denominator, and then you can combine your numbers together, but you cannot solve it the same way. So finding common denominators, we multiply the top and bottom by 2. We multiply the top and bottom over here by 3, and you go from there. And you can simplify it, but you cannot find x that way. So anyway, notice how I multiplied this one by 2 and this one by 3 instead of the entire thing by 6, which is the least common denominator. So just something to remember when you're doing this. We're only looking at equations, not expressions there. So when we have something like example 2, we have x squared over x minus 3, and that equals 9 over x minus 3. First thing I want to know is what x cannot be. X cannot be 0, because if I put a 0 in there, it's going to become undefined. But what I would do with this one is multiply the entire thing by x minus 3, and that will take care of my x minus 3's, so it will get rid of them completely, and I end up getting x squared minus 9. So x equals plus or minus the square root of 9, which is plus or minus 3. So the possible solutions are a positive 3 and a negative 3. One of the things you have to do is you have to check, because we're dealing with radicals right there. So we put this number in there for x, and one thing you'll notice is if I put a positive 3 in there, my denominator is 0. So positive 3 does not work, only negative 3 checks, so only negative 3 is my answer. All right, radical equations, bottom of page 232. Let's see what we can do here. Radical equation is an equation in which variables appear in one or more radicands. So that means that we have an x or some other variable underneath the radical sign. So it's part of the radicand, the number underneath the radical sign. Okay, why that happened? Alright, let's put a 1 there. Alright, so something like that. We've got a variable under the radical sign, and I'm not sure why they put that in there as an example, because they really don't solve it yet, and I don't think we're ready to solve it yet. So let's just jump up to example 3. 5 plus the square root of x plus 7 equals x. Alright, first thing you want to do is isolate the radical. Square root of x plus 7 equals x minus 5. And once you isolate the radical, you square both sides to get rid of the radical sign. So we have x plus 7 equals, and then we have x minus 5, the quantity squared. Use the FOIL method, and you get x squared minus 10x plus 25. Real easy to do because that's the difference of two squares. Alright, so that being the case, we set it equal to 0. So we end up with x squared minus 11x plus 18 equals 0. And then all I have to do is see if I can factor that down. And in this case, you can factor it down into an x minus 9 and an x minus 2. And that equals 0. So my x value is 9 or 2. Okay, so that works just fine. 9, we're going to check. We're going to stick that in here. And we get 18 minus 5, which is 13. And 13 minus square root of 6. Okay, that can work. Let's put the 2 in there. So we have square root of negative 1 minus square root of negative 1, and we're trying to subtract, and we do not get a real number solution there, so 2 does not check. So therefore, not going to work. In fact, if we put 2 in this problem right there, and we substituted a 2 here and a 2 here, well, 2 plus 7 is the square root of 9, and we add 5, and we get 5 plus 3. That does not equal 2. So that's another way to check to see if it's going to work or not, and in this case it does not. Okay, simplifying this, what we're going to do is we're going to isolate the radical. We'll put an x minus 3 over here, and we'll move the x plus 5 over. We did this last semester, so it shouldn't be too difficult to do. Square both sides, and we get x minus 3 over here, and we use the FOIL method to do the other side. So actually, let's go ahead and do that. Let's take that and multiply it by 4 minus the square root of x plus 5. It's not as scary as what it looks. First, 4 times 4 is 16. Outside, 4 times times square root of x plus 5, and we get a negative 4 square root of x plus 5. Inside, which would be these, and we get minus 4 square root of x plus 5. And then we take last, square root of x plus 5 times square root of x plus 5. All that means is my radical sign comes off, and we get x plus 5. So let's combine like terms. X minus 3 equals 16 minus 8 square root of x plus 5 plus x plus 5, And then we continue to combine like terms. So 16 and 5 is 21 minus 8 square root of x plus 5. Whoops. And we add 3 to both sides, or we subtract 21 from both sides since we are trying to isolate the radical. So we end up, oh, I'm sorry, I didn't add the x here, did I? Okay. So these two will cancel because they're on opposite sides of the equal sign. I mean, you can do the math and subtract x from both sides and they will disappear. I'm going to move this over and give me negative 24, and that equals negative 8 square root of x plus 5. Okay, so it looks a lot simpler now than what it did earlier. Now I'm going to divide both sides by negative 8, and that gives me 3 equals the square root of x plus 5. Square both sides to get rid of the radical, and I get x plus 5 equals 9. And then I can just find that x equals 4. And 4 checks when you put it back in, so that ends up being the answer. Okay, so finally, example 5, we're doing absolute values. And absolute values can be a little tricky just because it's so hard to know sometimes what an absolute value is. This is just asking, what does x need to be so that it's 5 away from 0 on the number line? So if I have my number line here, my two options are here or here. Both of those numbers are 5 away from 0 on the number line. So the x can be at negative 5, or x can be at positive 5. So I get two answers here. I get x is 5 or x is negative 5 or something like that. Okay, so knowing all that, let's look at an example here. Another example. Let's look particularly at x minus 3. This is example 5b equals 2. Okay, so what that's telling me is that x minus 3 has to be a distance of 2 from 0 on the number line. So if that's 0, x minus 3 can equal negative 2, or it can equal positive 2. So it's going to equal positive 2, or it's going to equal negative 2. Those are your two options. So what I'm going to do is I'm going to say x minus 3 equals negative 2. So x equals 1 in order to make it equal to negative 2. Or x equals 5 in order to make that equal to positive 2. So what we're finding out is, what does x have to be so that when we subtract 3 we get a distance of 2 from 0? Or what does x have to be so that when we subtract 3 from it we get a distance from 0 this way, which takes us to negative 2. Okay? Hopefully that helps you to understand absolute values. Sometimes they can be real tricky, especially when you read that blue box at the top of page 235. I mean, it just is kind of hard to understand what's going on. So hopefully that will help you to understand what is happening here. So your solutions are 1 and 5, and since we didn't use any radicals, we don't have to go back and check and see if one works, one doesn't work. So that's it for 2.5, one little video.